Welcome to question 10 of the 2013 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. For question 10 we have let f be the function with a domain of 0 to infinity, where the rule of f of x is 2e to the power of negative x over 5. A right-angled triangle OQP has a vertex at O, which is the origin, vertex Q on the x-axis and vertex P on the graph of f as shown. The coordinates of P therefore are given by x, f of x. For part A we're asked to find the area A of the triangle OQP in terms of x. So we know that the area of a triangle is simply equal to a half times the base length, and in this case the base length here would be equivalent to x. So we're going to have a half x times the height, which turns out to be f of x. So when we multiply it by f of x, that's simply 2e to the power of negative x on 5. And simplifying that down, we get an expression for a in terms of x is equal to, and the half times 2 would cancel, and we just have x times e to the power of negative x on 5. So that is the answer to part A of this question. From the examiner's report, we can see that 55% of students got that mark, and that most students knew how to answer this question. However, some left the equation unsimplified. So for basic simplification, for example the half times 2, that does need to be simplified in an exam. For part B, we're asked to find the maximum area of the triangle OQP and the value of x for which this maximum occurs. And now, because the question asks for two things, the maximum area and the value of x, we need to remember to answer both of those things. So as a prompt, we're just going to write at the bottom of our page that the maximum area is equal to, and we'll fill that out in a moment, and that occurs when our x value is equal to something, which we'll answer in a moment as well. Now if we try and do a min or a max problem, we usually look at the derivative a dashed of x equaling 0 in this case. And we know that the area in terms of x for that triangle was equal to x times e to the power of negative x on 5. So if we were to differentiate this, we'd need the product rule. And to apply the product rule, I'm going to let u equal x, which is one of the functions multiplied together, and v equal the second function which is multiplied together, which was e to the power of negative x on 5. So du dx is going to equal 1, and dv dx is going to equal negative 1/5 e to the power of negative x on 5. So therefore, a dashed of x, which is what we need to answer this question, is going to equal x times negative 1/5 e to the power of negative x on 5, which is just negative x on 5 e to the power of negative x on 5. And then we're going to add on to that du dx times v, which is going to be just e to the power of negative x on 5. So therefore, the equation that we're solving is negative x on 5 times e to the power of negative x on 5 plus e to the power of negative x on 5 is equal to 0. And to solve that, we're going to factorize out the common factor of e to the power of negative x on 5, which we'll leave behind, and just be careful when you do a step like this. It will be negative x on 5 plus 1 equals 0 still. So therefore, according to the null factor law, we could have e to the power of negative x on 5 could equal 0, or we could have negative x on 5 plus 1 could equal 0. However, there's no solution to this particular equation, and solving the second equation would give x equals 5 as the answer. So when x equals 5, that's when we have the maximum area. And to find that area, we simply substitute it into the rule that we had back up here. So that describes the area, so we're going to substitute it back into there. So the area when x is 5, if I just do that working here, is going to be x is 5 times e to the power of negative 5 over 5, which gives 5 times e to the power of negative 1, which can be written as 5 on e. So that is the maximum area for this question. So our answer, which is the maximum area and the value of x for which it occurs, is 5 on e for the maximum area when x is equal to 5. From the examiner's report, we can see that 26% of students got full marks for this question, with 46% of students receiving 0 marks. And the examiner goes on to say that it was necessary to have a result from Part A in order to make any progress in this question. The majority of students who obtained 2 marks produced additional incorrect solutions when they were equating the derivative to 0. So they made some error in solving the dA dx term equaling 0. And again, factorising and using the null factor law was the best way to solve that equation. For part C, we have let S be the point on the graph of f on the y-axis, and let t be the point on the graph of f with the y-coordinate of a half, and that's now illustrated in our new diagram in the top right-hand corner of the screen. And we're asked to find the area of the region bounded by the graph of f and the line segment ST, which is shaded here. So we're asked what this area is. So that area that we are asked to find can be found by calculating the difference between the area of a trapezium, which has the origin ST and the point directly under T as its vertices, and then we're going to subtract away the area underneath the curve of f of x, which is going to have a curve along the top, and we're going to need integration to do that. And to find the area of both the trapezium and the area under the curve of f, we're going to need to know what this x value here is. So what we do know about that point is it is the x value when f of x is equal to a half. So therefore we're going to solve the equation 2e to the power of negative x on 5 is equal to 1/2. And dividing both sides by 2, we get e to the power of negative x on 5 is equal to 1/4. And now expressing this in an equivalent log statement, we find negative x on 5 is equal to log e of 1/4. So therefore x is equal to minus 5 times log e of 1/4. And using one more log property, we can write this as x is equal to positive 5 by taking the negative up as the power. So we can do this as positive 5 times log e of the reciprocal of 1/4 is simply 4. So that means that this point here is simply 5 log e of 4. So now we can get back to our area calculation, and we know the area of a trapezium is a half times the 2 parallel sides added together. So in this case it's going to be 2, because we can find that this point S is 0,2 by subbing 0 into the graph of f of x. And then we add on the other parallel length, which is the y value of a half, and we multiply that by the length or the height of the trapezium, which is 5 log e of 4. Then we can subtract away the area underneath the graph of f, which is going to be the integral between 0 and 5 log e of 4 of the graphs rule 2e to the negative x on 5 dx. And now our job is just to evaluate and simplify that. So our area is going to equal, and this is, we'll do it in 2 steps, a half times 5 on 2 times 5 log e of 4. And then we subtract away from that the antiderivative. So the antiderivative of 2e to the power of negative x on 5. We divide by the coefficient of x, which is dividing by a fifth, which is the same as multiplying by 5. So that was a bit of a mouthful, but we do get minus 10e to the negative x on 5. And then we evaluate that between 0 and 5 log e of 4. And now on our next line, we're going to treat these two negatives as a positive, because they are consistent throughout our working. So when we subtract a negative number, it's the same as adding it on. So therefore the area that we're interested in finding is going to equal a half times a fifth is going to be 5 on 4 times 5 log e of 4, which gives 25 on 4 times log e of 4. And then we add on to that, and I'm just going to use a big set of green brackets to keep track of our working for this antiderivative that we still need to evaluate between 0 and 5 log e of 4. So first of all, we're going to substitute in that upper terminal, which would give 10e to the power of negative 5 log e of 4 divided by 5. And then we subtract away from that the lower terminal substituted in, which would be subtract 10 times e to the power of negative 0 over 5. And now with a little bit more space to work, we can continue to find this area as being equal to 25 over 4 times log e of 4. And then we're going to add on to that. And now 10e to the power of negative 5 over 5 log e of 4 can be written as 10e, and the 5's will cancel, just giving negative log e of 4, which is the same as log e of a quarter when we use the negative as the exponent of 4. And then we're still going to have subtract away 10 times e to the power of 0. And we know anything to the power of 0 is simply 1, but don't forget about the 10, so that's 10 times 1. So therefore the area, and we are getting close, is equal to 25 divided by 4 times log e of 4. And then we have added on to that 10 times e to the power of log e of a quarter. But e to the power of log e are inverse operations, so we just get 10 times a quarter. So we're going to write that as 10 over 4 is the same as 5 over 2. And then we're going to subtract 10, which is the same as subtracting 20 over 2. And we can now simplify this to be 25 over 4 log e of 4. And then we're going to have minus 15 on 2. So that is the answer to part C of this question. From the examiner's report, we can see that this was a very challenging question, with only 7% of students getting full marks for the question. And the examiner goes on to say that many students made a start, yet most had difficulty with the substitutions required to continue. Students who obtained 2 marks neglected to take into account the rectangle below the y equals 0.5 line. So they were dealing with a triangle, subtract the area under a curve, rather than a trapezium, subtract the area under a curve.